Now, let's take a look at part D. We are going to work on a problem that involves trigonometry. So let's first identify the form. The first attempt is to plug in the values, right? Plug in x. So when I plug in x, secant pi over 2 when x is approaching pi over 2 from the left. If you have trouble to remember what this is, I hope that you remember secant x is 1 over cosine x, okay? And cosine pi over 2 is approaching to 0, and actually it's approaching to 0 because pi over 2 from the left, it will be positive, approaching 0 from the positive sign, with a positive sign. So therefore, this is going to be infinity. And tangent x is, so I hope that you recognize tangent x. The graph looks like this. And this is the pi over 2. So from the pi over 2, you see that it's approaching infinity as well. So we have infinity minus infinity. Oftentimes, for trigonometric function, here's my suggestion. Write the trig functions in terms of the function that you like to work with. For instance, secant x, I prefer to work with cosine and sine. So I will write that as 1 over cosine. For tangent x, actually, if you see that, it's sine over cosine. Therefore, we see a common denominator, and you can quickly combine these two terms, which gives you 1 minus sine x divided by cosine x. When x is approaching pi over 2, this is approaching 0 with positive sign, and 1 minus sine of pi over 2 is approaching 1, so this is approaching 0 as well. Of course, both are from the 0. They're both approaching 0 with positive sign. Now, this certainly qualifies the L'Hopital's rule. So I'm going to write here, I apply the L'Hopital's rule. This is equal to net limit x approaches pi over 2 from the left. So derivative of the top is negative cosine. Derivative of the bottom is negative sine. And which gives you the limit of cotangent, right? Cotangent cotangent x. Cotangent x. Is this step really necessary? Not really. You can just discuss your solution from this step. For instance, you know cosine pi over 2 is approaching 0. Sine of pi over 2 is approaching 1. Therefore, you know it's going to be 0, approaching 0, and that's it. Or you can just discuss cosine x. If you remember the cosine x looks like this. And here, this point is pi over 2. And you can see that you reach to the same conclusion that when x is approaching pi over 2 from the left, it will be 0. So this is it for this particular problem.